welcome to the world of data center innovation with the iMasons podcast, discovering the people leading our industrial revolution. My name is Romain Tranchant, and today I'm joined by David G, independent consultant at Impleon. David focuses on the decarbonization and heat reuse of data centers. He has agreed to come on a podcast today to unpack the interactions between liquid cooling technologies and the need for heat reuse. Let's get right into it. Hi, David. Welcome to the podcast. It's a real pleasure to have you here today.
Hello, Romain. Thank you.
So, for those of for the members of our audience that might not know you already, do you mind actually presenting yourself and your field of work?
Yes, thank you. So, in short, I'm an independent consultant focusing on data center decarbonization and heat reuse. And my background is connected with heat transfer area, and I work with district heating, air conditioning, data center air cooling on chip immersion, and of course now more decarbonization and sustainability.
That's fantastic. Thanks very much for very encompassing presentation of yourself. I'd love for you to take us through a very important topic today: the actual relationship between the liquid cooling technologies and the fact that we're starting to see them more and more in data centers, and the fact that it enables heat reuse. I'm going to let you present on that topic. And look forward to hearing more about it.
Okay, let's start. So the topic is heat reuse and decarbonization because there is a new demand for environmental and social responsibility for the data centers. And I want to start from the map of data center heat reuse. If you look on that map, you will see that there is many projects realized in Europe and just some of them in US and nothing below on South part. And the reason behind that is the energy crisis, which has happened in Europe, and energy now is valued product. And this is why this energy from data centers substitute fossil fuel-based boiler houses and drive the cities for sustainability. However, I want to explain what is the issues with heat reuse in Europe and what is the opportunities in other parts of the world. So this is the swimming pool which we work with Mudon City. And after this increased prices for the gas, the management of the city decided to evaluate alternative sources of the heat. And instead of free gas boilers, each 900 kilowatt, we offer to use, in addition, just 100 kilowatt IT boiler, which allow to cut by half gas consumption. However, you see that the energy which is used by server is constant, but during the summertime it's fall down. And to cover this bottleneck, we introduced the dry cooler to have constant IT load and achieve that. So by this graph, I'm just explaining that the even swimming pool, it's not perfect match for the constant heat rejection from the data center. There should be something more stable, which will take that energy no matter what ambient air temperature, is it winter or summer. And this is why we explore the opportunity for hot countries or for hot places like California, Australia, Middle East, Egypt, and etc., where the cooling of data center is the issue. It's need a lot of energy. 40% of the energy goes to the just cooling, and at the same time there is a lot of investments to make fresh water by using reverse osmosis. So what is possible to do is integrate data center and thermal water distillation, which allow us to use this 5,000 meter cubic per day to cool down 10 megawatt data center installation. And data center will heat up the water for free, and that allow you to decrease the cost of fresh water. And this is a social pillar. And at the same time, we reduce the impact on energy grid from that center. So if we have 10 megawatt servers, we will not add anything for the cooling because we use this free cooling from the seawater. And this is the perfect combination because it's constant load during the year. But another things which we need to evaluate is capex for that center and capex for this desalination plant. So even the desalination plant is higher in cost, but the savings on that center facility side is cover this gap. And from the beginning, we are lower in the capital investments. So that brings the environmental value because we use less energy and we not pollute the environment by membranes, which is another embedded carbon. And we also cover the social pillar because we provide 2 times less cost for the fresh water for the people which are living in these dry areas but close to the sea. So this is about the heat reuse and what can be done in other way. Romain, another thing which I want to cover is about the new technologies, new demands for the servers. So of course, liquid heat transfer is a perfect match for the heat reuse because we have higher temperatures. But the driver for that, it's not the efficiency of the data centers. The main driver is a new AI dedicated software, new servers, which covering that demands. And if we look for new generation of the servers, the density of that racks can be 100 kilowatt in comparison with conventional 15 kilowatt. But at the same time, the space which is requested for that racks is much less because as we have liquid heat transfer, we don't need raised floor, we don't need ceiling, we don't need cold aisle and hot aisle, and that all is reduce the space free time from infrastructural point of view and increase density 7 times from the server point of view. So overall, 7 by 3 is 20 times 1 denser. So we need 21 times less space, and it's been embedded carbon of the building. However, there is also another important things is like facility water temperature. So with air-cooled approach, we need 20 degrees facility water to have 25 degrees in cold aisle. With liquid heat transfer, we can have 40 degrees, and it will be enough to cool down each component of the server. And another important thing is that in this case, we take away the fans and their energy consumption. And in new generation of the servers, it can be up to 35%. So 35% of the rack power goes to just supply fans energy. And if we look comprehensively for this transition from point of view of the facility side energy consumption, we need much less energy infrastructure. And this is why. So first thing is that we will have the same compute and same CPU and some GPU power. So compute power is the same. So this is why we compare apples to apples, but we will need much less racks, 126 instead of 130. The IT load is also go down because we take away the fans, and the temperature rise up, and the power IT load is go down. So this is why 8 times less energy consumption for the heat transfer infrastructure. And on top of that, we should provide interruptible power supply, and that's also go down. So overall, we have 1.8 megawatt power input instead of 3 megawatt. So imagine that just by changing this approach by servers and by the heat transfer method, we can increase by 40% our IT load, having the same limits in power supply from the grid. And if all data centers will shift for that approach, we can increase our capacity by 40% without any additional request from the energy grid. And Romain, you mentioned about the potential for the future, the potential for the new servers. So with even 3,000 watt GPUs, we are able to cover that with liquid heat transfer. And the main issue is, of course, with heat flux and the thermal resistance on the CPU and GPU level, but we are also in the beginning of that way, and we can handle that. And what is the role of Impleon in that journey is to accelerate that transition. So we provide open source design for the how to build servers, how to build racks, how to create this facility adopted for that new approach, and also how to build ecosystem which will take the heat and convert that to the valuable product, like in this case, fish farming and greenhouses. That is the our contribution to the data center industry. And when we're talking about the high capacities, about hyperscalers, usually they choose the low cost land, which is far away from the city, the low cost of the energy connection and energy price, and not driving by the heat reuse. So we decided to create open source underground modular data center, which can cover 3,000 racks and can be placed in the heart of the city to be closer to the heat user. And in that design, we take the approach with fixed concept, which ready to accept air-cooled racks, and in potentially will be ready for make transitions for liquid heat transfer. And this is how we present that. So in the first stage, we can use only door heat exchangers. By this, we take away the raised floors, hot aisles, cold aisles, and etc., and able to cover 14 kilowatt racks with the flow rate 20 liters per minute. And the same flow rate will be happen in 50 kilowatt racks. We will just serially connect the liquid heat transfer, which will add another 36 kilowatt and allow us to achieve 50 kilowatt per rack. But the flow rates remain the same. It's been the infrastructure remain the same. And if we look on the row level, this heat exchanger system, the same for 1 megawatt or 3.7 megawatt. Only thing which is changed is delta T, but the flow rate is the same. And if we look on the all data center level, it's also the flow rate is the same. The capacity is changed thanks to the different delta T. And I believe this is the answer for big data centers, how to be sustainable and how to bring sustainability to the big cities. It's a perfect conversion of renewable electric energy to the useful thermal energy for the cities. Romain?
David, thank you very much for that very interesting presentations. If you don't mind me, I've got a couple of questions, and I love when you and I have the time to talk, because I keep learning a lot. You have in your presentations the simplification of the data center from moving from air cooled to liquid cooled. One of the things that I didn't realize, so the fans of servers are using 10 or 20% of the energy of the facility.
So fans inside of server, I'm talking about these fans. They usually use around 5-10%.
5 to 10% of the energy of the server.
Yes, of the server. But when we shift for the new CPU and GPU, the airflow is need much more, that because the temperature of GPU is lower than the temperature of CPU, and the heat flux is higher, so thermal resistance become more, and this is why we need much more flow rate, airflow rate, and this is why we have such a big number for the fans energy consumption.
So what's interesting to me is that what you're presenting is a full cascading effect from moving the cooling method of the server all the way down to being able to reuse that heat. And I remember you and I talking in the past about the quality of the heat being extracted from the facility. And if my memory is good, we're talking about like the higher the heat coming out of the facility and the more use cases we can have for it. Can you take us through this in a bit more detail?
Yes, so exactly on this slide, you see that in air cooling, we can have 34 degrees inlet water, 44 outlet, but it's regarding the OCP servers, they can work with 35 degrees ambient air. But when we shift for the on-chip cooling, we can have 34 degrees inlet water for the door heat exchanger. After that, we have 44 outlet. And with on-chip, we can achieve up to 70 degrees outlet hot water. And that means that in this case, to achieve 70 degrees, we need a heat pump, which will allow us elevate this temperature for useful for district heating. However, in liquid cooling, we can achieve that without additional energy consumption for the pump with heat pumps, and that allows us to provide valuable temperatures with the same level which requested by the district heating operator, and that energy, that thermal energy, can be paid. So when you have low grade heat, it's not so easy to get money for that. But when you have high grade, the probability that you will pay for that is much higher.
And so I guess just to be extremely clear here, when you're saying high grade is just higher temperatures.
Yes. As higher temperature you have, more opportunities to use that in different applications you have.
Can you take us through the sort of applications at different like grades of heat? Do you have like a sort of a mapping out that says at 60 degrees we can do this, at 80 we can do this? Do you have the sort of like examples of these sort of things?
Yes. I want to just come back for this heat reuse global map. If you see that map we created in Open Compute project in heat reuse workstream, and also there we created the table where we show the temperatures range which we can have and the applications. So that white paper we can find on OCP heat reuse workstream, and there is a dedicated chapter which explains the opportunity of synergy between the data center temperatures between, let's say, 20 and 40 degrees and between 40 and 70 degrees, and which kind of application is used the same temperatures in their process, like food, pharmaceuticals, metallurgy, and other. So it's mean that if you have a data center and your neighbor is pharmaceutical production, and both have waste heat, it's not mean that the waste heat is not needed. It's mean that the data center can provide the waste heat for the pharmaceutical, and they will substitute their energy consumption, thermal energy consumption. This is the example of synergy.
Fantastic. It's such a broad topic, isn't it? We know there is data centers everywhere. We know there is other industries that could reuse the heat out there. How much opportunities do you see when you go talk to your clients around actually implementing some of those changes? Is that widespread? Is that something that comes fairly easily to actually figure out opportunities for heat reuse?
Of course, it's not easy for many different reasons. One main reason of that is legal departments. It's mean that when you want to connect that center with some of heat user, there is a mismatch between legal departments, responsibility, guarantee, and etc. And everyone want to be independent and rely on their own independency. So data centers don't want to be dependent from the district heating operator and etc. However, one of great examples is small server rooms, which are in the same building as the owner. And this data center, I mean server room, which is, let's say, 500 kilowatts, just make interjection to the ambient air. But it can provide the heat for the same building, for the same owner. And the matter of the heat reuse is just connection of two pipes between the outlet water from that center and the heating system of the building. So it can be done easily. This is what can be in an easy way. But if we talk about the big installations like a 300 megawatts, which is in a greenfield and in closest users is just some villages with 500 kilowatt capacity, and you have 300 megawatt data center, there is a real issue of matching the capacity which is needed by heat and the IT load which you have. So from that perspective, it's very important to make match between the heat reuse which you have in surrounding and building that center according to that needs. This is the main bottlenecks in heat reuse.
Fantastic. I can't thank you enough for coming today and taking the time. Is there any easy way that people can reach out to you in case they want to learn more or have questions around any of the topics we mentioned today?
Yes, sure. We have interesting group which name is Data Center Decarbonization in LinkedIn. There we're posting all the sustainable options for the data centers where people can have a look. And also you can reach me out through my LinkedIn profile, book a meeting, and I will be happy to support you in this decarbonization way of data centers.
All right, fantastic. I was just looking for the URL so that we can put it on the screen in a minute. It has been a very good group, and I must say, having posted a few times in this group, that that there is a real drive for not just heat reuse, but so many different aspects of data centers and trying to decarbonize the operations to build and so on. Can you give us a bit more maybe other areas that you're involved in, or other areas that you've been looking into?
Yes, so when we talk about decarbonization, it's not only the heat reuse, it's not only the source of your energy, it's also your software and your IT gear. So if you look for the software, you can reduce your servers by half or even by 70%. And if you reduce your IT load, it means that you reduce the core of the data center. You cannot achieve by liquid heat transfer such a reduction. We talk about, let's say, maximum 40-50% of the facility energy consumption. But when we talk about the software and optimization from that point of view, this is the real decarbonization. So you should look, first of all, for hardware utilization efficiency, which can show that, for example, you use only for 5% your IT equipment per month for full scale. It means that 95% it is idle, and it's not make sense to put your 5% load equipment to the immersion. It's first of all, you should work under utilization. And another important point is about transparency. So many data centers say that we are sustainable, we are green, and etc. And when customer asks the evidence of the fact that they are green or sustainable, some are happy to provide that information and some are not. So from this point of view, we need a transparency, and we need to look for the real driver, which will be valued by the customers. And in this case, we will know who is really sustainable and who is making greenwashing.
Mm-hmm. Fantastic. David, thank you very much for all of our audience. I've put the link to your group on LinkedIn at the bottom of this video. And by all means, have a look. It has been quite eye-opening for me to actually browse through the different posts I've been there. David, thank you very much for your time today. And for our audience, we hope that you enjoy the content that David has come to present. If you want more topics like this, or if you have any ideas for other topics, please reach out directly to me. I've put my email address directly on there. There is so much more that we want to bring to you, and we will be doing so in the coming weeks and month through this podcast. But by all means, reach out in case you want to learn anything else. So on that note, David, once more, thank you very much for coming on the podcast, and we will see you all very soon. Thank you very much.
Bye.